Okay, this is Unit 6, Lesson 7, Reasoning about Solving Equations, Part 1. And our focus question, how is balancing a hanger like an equation, and how is moving its weights like solving the equation? In the two diagrams, all the triangles weigh the same and all the squares weigh the same. For each diagram, come up with one thing that must be true, one thing that could be true, and one thing that cannot possibly be true. Okay, so I'm looking at this tape diagram, or the hanger diagram, and I notice that this triangle here must be heavier than the square. So that must be true. Or the square must be lighter than the triangle. And on this one I can see that the hanger is balanced evenly. So that must mean that a triangle weighs the same as 3 squares and a circle. So one thing that could be true is I could put a value on this triangle, and it could be that this triangle is 4 and the square is 2. That could possibly be true in this case. In this case over here, something that could be true is if the triangle is 5, then each one of these squares, if they were 1, if they weighed 1 pound or ounce or whatever weight they are, if those all are 3, then the circle could be 2. That would make it even on both sides so that the hanger would balance. So something that cannot possibly be true. So something that could not possibly be true is that the square weighs more than the triangle. And something that could not possibly be true here is the triangle cannot possibly weigh the same as the circle by itself, or the square cannot be the same weight as the triangle. Okay, let's look at 7.2. Hanger and equation matching. On each balanced hanger, figures with the same letter have the same weight. So all these W's here, they weigh the same as each other. The Z's here weigh the same. All the X's weigh the same, all the Y's weigh the same. And number 1 says, match each hanger to an equation. Complete the equation by writing X, Y, Z, or W in the empty box. So when we think of these hangers, we can think of this side equaling the same weight as this side since it's level here. So we can put an equal sign here in between all of these. And if I count the amounts on each side, I have 1, 2, 3, 4, 5, 6, 7. So if each square weighs 1, then this is a total of 7, and 7 is equal to a total of 3 W's plus a 1. So that's what I'm going to look for in my equations here. I'm going to look for a 7 that equals 3 W's plus a 1. So that is equal to 5. This one's 3. This one's 6. Okay, here we go. This one is equal to 7. And we have a plus 1, which we have here, plus 1. And we have 3 W's. So 3 times W plus 1 is equal to 7. 3w's plus 1 is equal to 7. So let's look at B. I have 2z's, and then I have another 3 here. And I have 1, 2, 3, 4, 5. So 2z's and 3 more, and 3 squares is equal to 5. So I'm looking for some, here we go, equal to 5 right here. So 2z's plus 3 square, or 3 is equal to 5. So the next one I have 1, 2, 3. I have 3 over here. So I'm looking for something equal to 3. Here we go. So 3 times something plus 2 is equal to 3. 3x's, right? 3x's plus 2 more is equal to 3. So 3x plus 2 is equal to 3. And the last one, I have 1, 2, 3, 4, 5, 6. So I have 6 is equal to 2y's plus a 3. 6 is equal to 2y's plus a 3. So now it says find the solution to each equation. Use the hanger to explain what the solution means. So as I'm looking at this first one, if I want to keep this hanger balanced, you've heard before what you do to one side, you do to the other side. That's what we're going to be doing here. If we take away this 1 over here, then we would have to take away 1 over here to keep it balanced. That means that 3w's would equal to, it had 7 and I took away 1, so it's 6. So 3w's are equal to 6. So that means that each w, if I make them into groups, that w, and that w, I make 3 equal groups. A w is equal to 2. So in this one, w is equal to 2. So let's go to this one. I have 3 over here and 5 over here. So if I take away these 3, I take away these 3, then I have 2z's, so I have to make 2 equal groups over here. So that means z is equal to 1. So I go up to here, I say z is equal to 1. Now here on C, I take away 2 on this side and 2 on this side, so I end up with just the x's. Right, I have 3 x's are equal to 1. So if I take that x, if I take all these 3 x's and divide it in this 1 into 3 equal parts, I'm going to take that 1 and divide it into 3 equal parts. Oops. So if I split this into thirds, if I split that 1 into 3 equal parts, I'm going to end up with 1/3, 1/3, and 1/3. So I'm going to take it and split it up into 3 equal parts. One, two, three. And then so each part, each x is equal to 1/3. So here I have 6 is equal to 2 y's and a 3. So I'm going to take away the 3, so I just have the y's. And then I end up with y, 1y, is equal to half of this, right? If I group this, I'm going to take half of that one for that y. I'm going to take the other half of the one for that y. So I end up with 1.5 for one y. Oops, y equals 1.5. There we go. So y is equal to 1.5. Okay, let's look at 7.3. Use hangars to understand equation solving. So we have 4 different hangars here. And here are the questions. Here are some balanced hangars where each piece is labeled with its weight. For each diagram, write an equation. All right, so let's do that first. So we have 7 on this side. So 7 is equal to 3x's plus 1. Hanger B, we have 31 on this side is equal to 2y's plus a 10. So 31 on this side, 2y's plus 10. For C, we have 6.8 on this side is equal to 2z's plus 2.2. And for D, we have 17 halves on this side is equal to 4 w's, 1, 2, 3, 4 w's plus 3 halves. So there's our equations. Explain how to figure out the weight of a piece labeled with a letter by reasoning about the diagram. And explain how to figure out the weight of a piece labeled with a letter by reasoning about the equation. So we're going to do these kind of at the same time. So I'm going to write the equation. We're going to do one at a time. We're going to do A first. 7 is equal to 3x plus 1. So if I do the same thing I did in the previous problem on 7.2, I would take away 1 from this side and take away 1 from this side, which would leave me with 6, right? So if I do that same thing on the equation, it would look like this. I'm going to take away the 1. This 1 here is this one here that I took away. And I'm going to subtract 6 from this side. So then I end up with, whoops, I'm going to take away 1 from that side. Seven minus 1 is 6 is equal to, so the 1 piece is gone, I'm just left with the 3 x's. Now I'm going to take this 6 and divide it into 3 equal parts because I have 3 x's. And if I take these x's and divide them into 3 equal parts, it's just going to give me 1x, right? So I'm going to divide each side by 3. So that would tell me that 1x is equal to 2. Okay, let's do the second one. B says 2y plus 10 is equal to 31. So the first thing I'm going to do is subtract the 10, and I'm going to subtract 10 here. So on my equation, I'm going to subtract 10 and subtract 10. So I have 2y's, that's what I have left, 2y's, is equal to 31 minus 10 is 21. So now I'm going to take that 21 and divide it by 2. So 21 divided by 2 gives me 10.5. And the 2 y's I also divided by 2, which gave me just 1 y. 1 y is equal to 10.5. Okay, let's look at C. I have 6.8 is equal to 2z plus 2.2. So the first thing I'm going to do is take away this 2.2 here and take away 2.2 here. And let's see what that leaves me with. It's going to leave me with the 2 z's by themselves. So I'm going to take away 2.2. And I'm also going to take away 2.2 from this 6.8. So now I have 2 z's is equal to 4.6. 2 z's is equal to 4.6. So I'm going to take that 4.6 and divide it into 2 equal pieces, because I have 2 z's there. So if I take my 2 z's and divide them by 2, I end up with 1 z. If I take my 4.6 and divide it by 2, I end up with 2.3. Okay, let's go to the last one. The last one says 4w plus 3/2 is equal to 17/2. So the first thing I do on my tape diagram, I'm going to take away the 3/2, so I'm just left with 4w's. So I'm going to take away the 3/2 over here. So if I take away 3/2, I end up with only 4w. And I'm going to take away 3/2 from the 17/2. So I end up with the 4w's are equal to 17/2 minus 3/2 would give me 14/2. And at this point I know 14/2 is 7. So I'm just going to change that to a 7. And then I divide this side by 4. I take that 7 and divide it by 4. So I take this 7 and divide it by 4. So I end up with w is equal to 7 divided by 4, which is 1 3/4. Okay, so let's summarize what we just learned. How does a balanced Hangar diagram relate to an equation when solving for an unknown value, and how does it not relate? So we know that what we do to one side we have to do to the other side to keep the Hangar balanced. And we also know on the equation what we do to one side we have to do to the other side also to keep this equal. So when we take away parts of a tape diagram, so here's a Hangar diagram. This Hangar diagram has 5 is equal to 2 x's plus a 1, right? If these are equal to 1 here. So this Hangar diagram represents 5 is equal to 2x plus 1. And if we take away this 1 from this side and this side, like we do here, we take away the 1, we take away the 1. we end up with 5 is equal to 2x plus 1. If we take away 1 from each side, we end up with 4 is equal to 2 x's. And that's what we have here. 1, 2, 3, 4, and 2 x's. And then we take that 4 is equal to 2 x's. And since we have 2 x's, we want to divide it into 2 equal pieces. We want to divide this side into 2 equal parts and 1 part for each x. So if we divide the x's by 2, we end up with just one group, right? One group with an x is equal to 2. So we divide by 2, x is equal to 2. And this is what we're left with. X is equal to 2.